Transceivers with data rates of 100 gigabit per electrical lane or more, so in other words we're talking about 800 gig and 1.6 terabit transceivers, all are extremely power hungry, even the short range ones, right? Well, that's not quite true anymore. If you want to find out why, stick around and we'll check it out. So let's start off by talking about the fundamental challenge of high data rate transceivers. Now the problem is that with increasing data rate per electrical lane, it also becomes increasingly more difficult to maintain a good signal integrity. So why is that becoming such a challenge now? I mean, we've been continuously increasing the data rate of transceivers. Let me explain over here. So basically, what happened is we postponed the necessity to increase the data rate per electrical lane by simply adding more. And that ended up with the QSFP with 4 electrical lanes and the QSFP DD and OSFP with each 8 electrical lanes. However, now we're talking about data rates which made it necessary to also drastically increase the data rate per electrical lane. But as I mentioned beforehand, it's also extremely difficult to maintain the signal integrity for these high data rates. And that is why the first designs of 800 gig transceivers, which use 100 gig per electrical lane, included a digital signal processing circuitry, or short DSP, which does a full retiming of the signal both on the transmit and the receive side of things. And the downside was that then the power consumption actually went up to 20 watts for one transceivers, and we're talking about short range here. Now, the modern network equipment, so we're talking switches and network interface cards, they actually have very powerful ASICs built in, and they are actually capable of compensating signal degradation quite well. So the question was, can we maybe use the ASICs to take care of that so that we can get rid of the DSP in the transceiver? And the answer is yes. And the first version was then the so-called LRO, so the linear receive optics, which got rid of the DSP for the receiving side. And the resulting reduction in power consumption was at roughly 30%. In other words, we then ended up with a power consumption of roughly 14 watts. Then we have the LPO, so the linear pluggable optics, and that got rid of the DSP altogether in the transceiver, and the reduction in power consumption compared to the fully retimed, so the full DSP version, was more than 50%. In other words, we are now at a power consumption of less than 10 watts. Now, getting rid of the DSP is a good thing in regards to the power consumption, but it actually makes the interoperability more challenging because we're not just having the interoperability between the two transceivers, we now also have the interoperability including the ASICs built into the equipment of different manufacturers. So how can that be maintained? Well, the good thing is that the LPO MSA, which is made up of equipment manufacturers, so network equipment manufacturers and transceiver manufacturers alike, now in 2025, they have released the first 2 specifications. And that is the 100 gig DR specification, so for the 100 gig per electrical lane and parallel single mode, as well as the 400 gig FR4, which is also 100 gig per electrical lane, but then using CWDM. Now the point is, this MSA doesn't just specify the transceivers, but it also specifies the reference design from the ASIC onwards, so for the network switches and network interface cards as well. So does that mean now that LPOs will become the standard technology for 800 gig transceivers? Well, no, because LPOs have a distance or achievable distance of 500 meters. In other words, for the longer distances, we will still maybe need LRO or maybe even the fully blown DSP version. And for 1.6 terabit transceivers, we're also talking about data rates of 200 gigabits per electrical lane, and that comes with its own challenges. But the point is, we're at the beginning of this development cycle, and as usual, with the advancements of technologies, the power consumption will continue to go down and the reaches will continue to go up. So, I hope you learned something today and that you enjoyed this video. If so, please leave a comment. And of course, remember to follow our channel so you get your regular dose of brain snack. Until next time, bye-bye!